Good evening, everyone. Right. Welcome back to our sessions on Numpy. So it's our day 9. So we are almost approaching to the last of these sessions of our program. So we'll quickly recap what we have covered in the last session. Then now we'll start the new topics for the day. So in the last class, we have understood what exactly is Numpy and what are the advantages of using Numpy, right? So we understood the purpose and the history of NumPy. Next to the history of NumPy, we understood the advantages of NumPy. We understood NumPy is actually, very fast. It consumes the arrays that we create using NumPy module will consume very less memory. And we also understood the similarities and the differences between the traditional Python objects list and NumPy ND arrays. Next to that, we have understood the number of approaches, different approaches for creating ND array objects. Like we have understood array function, where array function helps us to convert any traditional Python object to ND array object, an array object. Arrange function is also we have discussed. Then zeros, ones. So all these functions we have discussed for creating. What is the purpose of these functions? They help us to create ND array objects. It might be one-dimensional, two-dimensional or n-dimensional arrays. In the last class, we understood what is basic indexing. How basic indexing has to be performed on one-dimensional, two-dimensional and n-dimensional arrays. Next to understanding basic indexing, we have also understood advanced indexing. So this particular topic we are listening for the first time, especially in NumPy, because so far there is no concept of advanced indexing. But in NumPy, on ND array objects, we can also perform advanced indexing. We know what is indexing. What is indexing, guys? Indexing means accessing one value at a time. A single value, a single element is nothing but basic indexing. But what is advanced indexing? Advanced indexing is nothing but it's a type of indexing which allows us to access multiple elements, where these elements may or may not be in a specific order. The order may or may not be, of these elements, they can be same or different. And next to the advanced indexing, we also understood slicing operations on different dimensional arrays, one-dimensional, two-dimensional and n-dimensional arrays. So guys, whatever we have covered in the last class are very important concepts. Basic indexing, advanced indexing and slicing operation on ND array objects. All these are very important. Okay, so today we are going to complete NumPy, okay, where we have few more topics left out like arithmetic operations on ND array objects. We know what are arithmetic operations. What are the arithmetic operations that we have learned in operators? Under operators topic, did we learn arithmetic operators? Yes. Arithmetic operators are nothing but addition, subtraction, multiplication, division, floor division, then modulo and power or exponent. All these are arithmetic operators that we have learned under operators topic. So these arithmetic operations we are going to perform on ND array objects. Right? Next to the arithmetic operations, we'll also understand the statistical operations. The statistical operations that we have that we can use on ND array objects, and we can sort and delete the values of ND array objects. That means within the ND array objects, we can sort the elements as well as we can also delete the specified elements. So that can be done. So these are the topics that we are going to cover in today's session. So this will be the agenda for the day, guys. Right? So pay attention. As usual, I'll start with the first topic, arithmetic or matrix operations on ND array. Right. So in general, what are operators? What are operators, guys? Operators are nothing but symbols. Operators are nothing but symbols. What is the purpose of these symbols? They help us to do some operations. They help us to do some operations. Right? So in order to do these arithmetic operations, we have functions in Numpy module. We have functions. What are these functions? Add function, subtract function, multiply function, dot or matmul, matrix multiplication function, okay, divide function, floor divide function, mod function, and power function. So all these functions from Numpy help us to perform arithmetic operations. Okay. So let us understand one by one. If you remember, under operators we used symbols plus, minus, asterisk mark, then slash, double slash, percentage, and double asterisk mark. So instead of using these symbols, let us go and use the functions that we have from Numpy. Okay, we know that Numpy allows us to perform the vector calculations. Okay, so let's see what will be the output for these functions. Right. Let me start with the add function initially. So what does add function does, guys? What does add function does? Add function helps us to add the elements. It helps us to add the elements of two objects, two n-dimensional array objects. Whatever we specify within the add function, the elements, the corresponding elements gets added and it returns the output. So that is the purpose of add function from Numpy. Okay, so here are some few examples. The syntax is very simple. Numpy dot add. Numpy dot add. As we are using add function from Numpy, so we have to specify Numpy initially. Okay, like how we have specified array, np dot array, np dot arrange, np dot ones, np dot zeros. So all these functions are coming from Numpy module. Okay, since I am importing the module as it is, I have to use the prefix as Numpy. Right? So let me start with the example. What am I doing in line number 410? In 410, we are coming up with a list object. This is a list object. Okay. But precisely it is a nested list object. If you observe properly, we have list objects inside the list object. So it is nested list. Then what about L2? L2 is also a nested list. Observe carefully. Both L1 and L2 are two list objects of size 2. Of size 2. Now, I'll use the array function from Numpy because we are supposed to use it on arrays, right? So, these list objects that I have, I'll be converting them to array object. So, for that, I have to import Numpy initially. Import Numpy as NP. Okay. Post executing this line of code, only after importing numpy as np, I can use any function from numpy. Okay, so np dot array of L1, which means I'm converting this L1 list to array object. So this will return me a two-dimensional array. This will return me a two-dimensional array. And where am I storing it? I'm storing it in A. So A is an array of size 2, comma 2. In the same way, I'll use L2, I'll pass it into the array function. So this will also return me a two-dimensional array of size 2 by 2. Yeah, storing it in B. Okay, so when I print A and B, see, so these are my two array objects, two-dimensional arrays. And let me add the elements of these two array objects. Is that possible? Yes. Array objects support vector calculations. They support vector calculations. When I add A and B, see, when I add A and B, what happens? The elements, the values at the corresponding position gets added. They get added. So what will be the output is 10 plus 1. It's 11. 20 plus 2. 22. 30 plus 3. 33. 40 plus 4. 44. Okay. So this is how the addition will be done by using the add function. The addition of the elements, the corresponding elements will be returned as output. So can you tell me what will be the output for line number 418? What will be the output for line number 418, guys? Where I am using add function. Add function from numpy. So the values for C will be 11, 22, 33, 44. See? The output is 11, 22, 33, 44. Is that clear? Simple. Let me go with the sign, the symbol. So far, in the last example, whatever we have discussed, what we have done, I used add function from numpy. Right? But now, let me use the symbol, plus symbol instead of add. What will be the output? Let me go and check. So I'm coming with the same list objects, the two list objects. Then these list objects I'm converting into arrays, array 1, array 2. So I'm printing these array objects A and B. So that means the arrays are also same. There is no change with respect to the arrays. Okay, they are same. Now, instead of add function, I'll go and use plus. What does plus indicate? Plus is actually indicating addition. Addition operator, guys. So that means, first of all, can I add two array objects using plus operator? Addition operator? Yes. Vector calculations are possible. So when you try to use this plus symbol, okay, the plus icon, So what happens is, in the same way, whatever the add function have done, in a similar manner, the plus operator will do the same and it returns the output. The same output will be returned. See, there is no change with respect to the output. Even though if I go and use add function or plus icon, okay, it has returned me the same output. There is no change with respect to the output, guys. There is no change with respect to the output. Now, let me go to the subtract. Add function is actually adding the elements, the corresponding elements. Subtract function will return as the difference of the corresponding elements. Okay, so the syntax is again the same, only the function is being changed. Instead of add, you'll find it as subtract, right? So I'm taking two list objects, L1, L2, the same list objects I'm using. Okay, so these list objects, we are converting them to array objects using array function from Numpy. And these arrays, we are going to store in A and B. A and B. Let me print A and B. So the same array objects. Okay, even the array objects are also same. Right. Now, what am I doing? I'm using subtract function from Numpy. Subtract function I'm using from Numpy, where I have passed two array objects inside it. What are A and B? A and B are two array objects. When you pass both these array objects inside the subtract function, what happens? The elements that we have at the corresponding places, like 10 and 1, 22, 30 and 3, 40 and 4. So the difference of the corresponding elements will be written as output. So what will be the output for line number 4443? 10 minus 1. 10 minus 1. It will be 9. 20 minus 2. 18. 30 minus 3. 27. 40 minus 4. 36. So when I execute line number 443, this will be my output. See? 9, 18, 27 and 36. Okay, so this will be the output for line number 443. Hold on, can I also use minus symbol instead of subtract function from Numpy? Yes. As array objects, as these ND array objects support vector calculations, we can directly use the operator instead of subtract function, where it returns me the same output. The output will be same. Okay, there is no change with respect to the output. Observe. See, if we observe the output, both C and D, both the arrays are same. The elements, if you compare, both C and D are same. There is no change in the output, guys. There is no change in the output. Is that clear? Right. Let me go to the next function in Numpy, that is multiply. What does multiply function does? Multiply function will help us to return the multiplication of the corresponding elements of two array objects, two n-dimensional array objects. So I'm taking the same list objects L1, L2, and these list objects I'm passing to array function. So this will return me two-dimensional arrays where I'm storing them in A and B. Okay, so if you observe, this is A and this is B. This is A and this is B. Right. So tell me what will be the output for line number 461. What we are doing in the next line? I'm using multiply function. I'm using multiply function. Okay. So what does this multiply function does? The multiply function will actually multiply the corresponding elements. So 1 with 5, 2 with 6, 3 with 4 and 4 with 3. So what will be the output, guys? The output will be 1 5s are 5 and 2 6s are 12, 3 4s are 12 and 4 3s are also 12. So this will be a two-dimensional array returned as output. The same array will be written as it is as output. Let me execute and cross-check. See, is that same? Yes, 5, 12, 12 and 12. Right. So what if I use the star symbol instead of multiply function? We know star is also used as multiplication operator in Python. Right. So can I use this star symbol for multiplying two n-dimensional array objects? Yes. Yes. The reason behind that is, these n-dimensional arrays, whatever we have, they do support vector calculations. Okay. So the vector calculations are possible. So this allows me to return the same output, guys. There will be no change in the output. 5, 12, 12 and 12. Is that clear? See, what we are trying to understand here is understanding the differences between how the operations, the arithmetic operations that we perform on, the traditional objects and these n-dimensional array objects is what we are trying to understand. Okay, so if you perform the same on list, taking two list objects and perform the same, check whether they return you the product of the values or what it is returning. You have to check and let me know. But in case of array objects, is this returning the product? Yes, they do. Right. In the same way, I'll go for matrix multiplication. So far, I just understood only the concept of multiply. So there is a function like dot function or matmul. What is this matmul? Matmul is nothing but matrix multiplication. I hope all of you are aware of matrix multiplication. Right. So how matrix multiplication generally we do, if you want to perform the matrix multiplication, okay, so you can also achieve it using matmul function. You can achieve it using matmul function. So for that, I'm going to consider two list objects, L1, L2. Then I'm converting these list objects to array objects by using array function from Numpy. Okay, so I'm taking these A and B, nothing but two array objects, and I'm passing to the dot function. So dot is nothing but it is actually performing the matrix multiplication only. Okay, so what will be the output? Can you guess me what will be the output for line number 481? Let me print A and B. So this is A and this is B. And tell me what will be the output for line number 481. Come on guys. What will be the output for line number 481? What do you think? The output will not be 5, 12, 12, 12. No. What happens is the first row will multiply with first column. Okay, this is what we know. We have understood as part of matrix multiplication. Right? So 1 gets multiplied with 5 and 2 gets multiplied with 4 and the product of both gets added. So 1 5s are 5 plus 2 4s are 8. 8 plus 5 will be 13. So the first element will be 13. Okay. Then the same first row will be multiplied with the second column. 1 6 are 6. 2 3s are also 6. So what will be the output? 6 plus 6 will be 12. Then the same happens for second row. 3 5s are 15 and 4 4s are 16. 15 plus 16 is 31. 3 6 are 18. 4 3s are 12. 18 plus 12 will be 30. So this will be the output of dot function or matmal function. You take any function, at the end it is, performing matrix multiplication. Okay, either you go and you take dot function from Numpy or matrix multiplication, matmal function from Numpy, it will return you the same output 13, 12, 31, 30. For this case, I'm talking about this specific case. Okay, let me cross check. See, 13, 12, 31, 30. If I do the same using matmul, here also it will be the same. Here also it returns us the same output, guys. Right? So additionally here in NumPy we have two functions, dot and matmul, for performing matrix multiplication. Then let me go to the next function. It is divide. It is divide. So what exactly does divide function does? We know divide function will, it performs the division. Am I right? Will it perform the division? Yes. So when you take divide function, the corresponding elements of the two end array objects gets the division performed and the results will be displayed. Okay. So if you see here, I am considering the same two list objects. Then I am converting these list objects to array objects. So these are my two arrays. 10, 20, 30, 40 is nothing but array A and 1, 2, 3, 4 is array B. It is array B. Now, what if I perform divide? If I go with the divide function from NumPy, what will be the output? We know division operator. Backslash, guys. 10 divided by 1. 20 divided by 2. 30 divided by 3. 40 divided by 4. So that will be given as output. Can you guess what will be the output? What is 10 divided by 1? We have discussed all these topics in operators. I don't know why you guys are sitting idle. Why you are sitting silent? Respond to the questions. 10 divided by 1 is nothing but so here is an important thing that has to be noticed. What is the operator that we are using? Division operator. Do you remember when we have discussed division operator? Didn't we discuss the division operator always returns us a float value as output? In the same way, divide function from numpy also returns only float values as output. So the output will be 10.0. The output will be 10.0, 10.0, then 10.0, 10.0. It will not be 10, guys. This is very important. Okay. Why? The reason behind that is we are performing division. A division will always return as float value as output. It does not return as 10. This is int value. Right? So let me execute and show you the output. I'll perform line number 499, and if you observe closely, is it 10 or 10 point? All of them are floating values. I can perform the same, I can get the same output using the slash, backslash. When I use this backslash, even this returns me the same output. This is nothing but division operator. See, 10 divided by 1 will be 10 point. 20 divided by 2, 10 point. 30 divided by 3, 10 point in the same way. Clear? Yes. Let us go to the next function, floor division. It is floor division, but the function that we have in Numpy is floor divide. Okay, so what exactly does floor division does? Floor division also performs division. Okay, but instead of that, it returns only the floor value. So when we are using this floor divide function on n-dimensional array objects, what happens is the corresponding elements, whatever it performs the element wise floor division, and the results will be displayed. Okay, similar, whatever the functions that we have discussed so far, it might be add, subtract, multiply. All of these functions are performing element wise calculations. Yes. So let me perform floor divide function. What am I doing in line number 510? I am coming up with a list object L1, L2. Two list objects is what I am creating. Okay. Then next to that, I am converting these list objects to array objects. We are converting the list objects to array objects using np.array function. Done. So here are my two arrays. 10, 20, 30, 40 is array A, and 1, 2, 3, 4 will be part of array B. Now, when I say np.floor underscore divide function, okay, so I'm using floor divide function from np, numpy, okay. So what am I passing to the floor divide function? I should pass two n-dimensional array objects. See, the syntax is pass two nd array objects. So I'm passing two nd array objects. Done. So this will return me what? What will be the output for line number 517? Will it return 10 point or only 10? Good. It will return me only 10. Why? Because all of the inputs, if you observe closely, all of them are int type values. Okay. So, and we know that floor division will always return the floor value. So the output will be 10, 10, 10, 10. I can get the same output from the double backslash icon. Okay, this double backslash represents floor division operator. So I'm using this floor division operator and I'm going to perform the floor division on the two arrays A and B. So this will return me the same output. The same output will be returned. So let me execute line number 520 and I'll print the values, the results of D. If you observe, the output is 10, 10, 10 and 10. Finally, we had one more function. What is the next function? It is mod. What does this mod function does? Mod function will help us to perform the modulus operation. Mod function from Numpy will help us to perform the modulus operation on the elements of n-dimensional array objects. What does mod operator does, guys? Modulo operator, do you remember? Where we represent this modulus operator with percentage. So what does this modulus operator returns? It returns as the remainder. It returns as the remainder. I hope you remember. So it performs the same division, but it returns the remainder of the elements. So when I'm going to use this mod function on two n-dimensional array objects, even it performs the element-wise modulus operation and it returns the remainder. So what I am doing here, I have two list objects. First of all, taking the same list objects again and again, because these numbers are very easy for us to calculate and tell us the answer, right? Don't assume why are we considering the same elements time again. Why did we consider the same example time again is, it will be very easy for you for answering, right? So what am I doing? I'm converting these list objects to array objects, storing in A and B. So here are my two array objects, two-dimensional arrays. And then I'm going to use the mod function from numpy. Okay. So where I'm passing the two ND arrays, two-dimensional arrays, I'm passing to the mod function where it returns the remainder of the corresponding elements of these array objects. So what will be the output? Yes, it will be zeros. Why? All of these elements, if you observe, 10 divided by 1 is 10. Right? So what is the remainder? Remainder is obviously 0. It is perfectly dividing in the same way. 20 divided by 2, 10. The remainder is 0 again. In this way, if you observe, all the elements are actually dividing them perfectly. So the remainder will be 0. Remainder will be 0. Can I achieve the same output using percentage symbol? What exactly does percentage tell us? Percentage means it's nothing but modulus operator. Okay, under arithmetic operators, we have discussed modulo operator. Yes. So that modulus operator we represented with percentage. Right. So I'm going to achieve the same output even if I go with percentage. Done. Observe, it's done. Simple. So whatever the arithmetic operators that we have discussed earlier, we are recapping them again, but this time we are using them on ND array objects. n-dimensional array objects. The final function that we have under arithmetic operations. Under arithmetic operations is power function. What does power function does? Power function will return as the exponential of the elements, the corresponding elements of the two n-dimensional array objects. Okay, so whatever the arrays that you pass, based on the position, it returns the exponent of the elements. So for that, I am using the power function. So I am creating a list object initially, two list objects. Yes. Then converting these list objects to array objects. Done. And displaying the values of A and B. So tell me what will be the output for line number 553. This will return me, np dot power of A comma B means it takes the corresponding values and it returns the power. 10 power 1, 10, 20 power 2, 400, 30 power 3. Probably 3 power 3 is 27. So it will be 27,000. Right? 40 power 4. 4 power 4 is 256. So 256 and 4 zeros. So that will be the output. Let me execute. See. I hope you're getting the point, guys. And finally, I'm going to achieve the same output using double star. I can get the same output using double star, as we have used this double star symbol for power operator in arithmetic operators. Yes, the output will be same. I am storing it in F. See, if you compare both C and F, the values, the results will be same. See, either you go and use the function from the Numpy, or you can go and directly use the symbol. So that is the advantage of n-dimensional arrays, array objects. Because the objects are arrays, we are able to perform the vector calculations. Okay, right. So this marks the end of arithmetic operators, arithmetic operations. Next to that, we have statistical operations. So what are these statistical operations? Again, in NumPy, we have functions that are related to, statistics. Okay, so here are a few functions. We are going to use all of these functions, guys. And these functions are, again, they are not new for us, because from our school days itself, we are learning these functions as part of statistics, mathematics. Max function, min function, mean function, median function, var function, std function. So max function, min function, mean function, median function, variance function, standard deviation function. Okay, right. Then these statistical operations that we are going to perform on the n-dimensional array objects, we can also perform them separately. In a sense, we can perform these statistical operations on column wise as well as row wise. Even that can be done. How? By changing the value for a parameter axis. There is a parameter called axis, and when you keep the axis is equals to 0, it is for columns, and when the axis is equals to 1, it means rows, for rows. So let us remember these two values. And let me start with the first function, first statistical operation, A max. So what does this A max function does? Let us understand this. A max function will return as the maximum element of the entire ND array. The entire ND array object, the maximum element will be written by A max function. So this A max function have three different syntaxes. It's nothing but we are changing the axis value. Okay. So in general, the syntax is numpy dot A max of n dimensional array object. When you pass this object, out of all elements of this object, the maximum value will be returned by A max function. The max. What if you specify axis is equals to 0? That means it checks for the maximum value based on columns. For each and every column, it returns the maximum value. What if I keep it as axis is equals to 1? It goes for rows, it checks for each and every row, and it returns the maximum element from each and every row. So, in short, the syntax is only one. But the axis parameter by default takes the value as none. I hope you remember none data type. So by default, the value for axis is none. But when you want to change it for 0 and 1, what does 0 means? Columns. What does 1 means? Rows. Okay. So accordingly, when you want the maximum element from all the columns, go with axis equals to 0. When you want the maximum element from all the rows, go with axis equals to 1. Okay. So let me start. Initially, I am importing numpy as np. Only if I import numpy, I can go and use the functions that are available in numpy. Okay. So I'm importing numpy as np. Then next to that, what is this? It is a list object of size 3 because I can clearly see it is a nested list object. It's a nested list. Okay. And I'm converting this nested list to a list object. I'm converting it to array. Can you tell me what will be the dimension of A? Can you tell me what will be the dimension of A? What am I doing here? What are we doing, guys? I'm using array function to which I'm passing the list object. So this list will be converted as array. But what dimensional array? Will it be one dimensional, two dimensional, or three dimensional? What will be the answer, guys? It will return me a two-dimensional array. It will return me a two-dimensional array. See, what is the size of this two-dimensional array? 3 by 3. 3 rows, 3 columns. Yeah, it has written me a two-dimensional array of size 3 by 3. Right? Yes. Now, what am I doing is, I'm going to use Amax function from Numpy. I'll be using Amax function from Numpy. What does Amax function does? Amax function will return me the maximum element present in this array object. The two-dimensional array object. Tell me what will be the output for line number 574. What is the maximum element of this entire array? I see the maximum element is 4. So that 4 will be stored in max. And I'm printing this with a message. Using print function, I'm going to print with a message. The message will be displayed as max element is equals to, then the value of max will be printed. So the output for line number 575 will be 4. Good. Now let us come to 577. What is the difference between 574 and 577? Here I did not pass any value for the axis, but here I am passing the value for axis. Right? So as I am passing the value for the axis, what is the value that we are passing? Axis is equals to 0. What does that mean? Axis is equals to 0 means columns. It means columns. So that means for each and every column, it is going to return as the maximum element. So tell me what will be the output for line number 577. In total, we have 3 columns. So that means we should get 3 values as output. We should get 3 values as output. What will be the output for line number 577, guys? For this column, the output is 4. For this column, the output will be again 4. But here, the output will be 3. So, the output for line number 578 will be an array of 4, 4, 3. It will be output like 4, 4, 3. No. Column wise. These are called columns. Column 1, column 2, column 3. Yes. Clear? Then, in the same way, let us go and get the result for line number 580. I'm using Amax function, but what are the changes that I'm making? Instead of getting the maximum element from each and every column, let us get the maximum element from rows. How can you achieve from rows? We can achieve from rows by keeping the axis value as 1. When we say axis value as 1, so this will return me the maximum value from each row. So what will be the output, guys? Yes, 3, 4 and 3. So for line number 581, if I execute, the output will be 3, 4, 3. So let me start executing from here, line number 574, and let us cross check our results. Okay. Sorry, my bad. Here also we have 4, right? So the output here should be 4. It's not 3. This should also be 4. Fine. So I'll start executing from line number 574, and the results are like this. So initially for the first line, we have to get the max element as 4, and for the next case, it should be 4, 4, 3. Yes, 4, 4, 3. And for the last case, it should be 3, 4, 4. Exactly. So this is how we use Amax function to return the maximum element of the entire array. Then from all the columns, we are going to get the maximum element, and from all the rows also we can get the maximum element. Right? In the same way, we also have amin function. Like how we have understood Amax, in the same way we have amin function, guys. What does this amin function does? Amin function will return the minimum element. Amax returned as the maximum value. Amin will return as the minimum value. Amin will return as the minimum value. So the syntaxes are again same. Only the function is being changed. If you observe, okay. So when I say a min of array object, it will return the minimum value of the entire array. And if the axis is equals to 0, it means for columns. And if I keep the axis is equals to 1, it means for rows. Right? Yes. I'll start it from line number 590. I'm creating a list object, and this list object I'm converting it to array. So what is the shape of this A? It is two-dimensional array of size shape 3, 3. Of size 3, 3. So when I say np dot a min of a min function will return us what? The minimum value, the minimum element of the entire array. So what should be the output? Obviously the minimum value is 1. So for line number 595, the output will be 1. Then coming to line number 597, what are the changes that we have done? I want to get the minimum element from all the columns. From all the columns, I want the minimum element because I have specified it as axis equals to 0. As I have clearly specified it as axis equals to 0, it returns me the minimum value from all the columns. The output will be like 1, 2 and 1. So this will be the output for line number 598. And finally for line number 600, where I want the minimum value for all the rows. For all the rows, so it considers each and every row, it identifies the minimum value. What will be the output, guys? The output will be 1. Here also it is 1. But in the last row, the output is 2. So this is how the minimum values will be identified from all the rows and they will be returned as output. So let me cross check the results. I'll start from 594. So initially the first value, the output is 1. Correct? Then next case, it should be 1 to 1. Did we get 1 to 1? Yes, exactly 1 to 1. 1 to 1. And in the last case, the output should be 1, 1, 2. 1, 1, 2. Done. So we are done with a min function as well. Now let us go to the third statistical function. It is mean. What is mean? What do you mean by mean, guys? What do you mean by mean? Mean is nothing but average. Mean is nothing but average. How do you calculate average? Average is calculated as summation of all the elements divided by total number of elements. Yes. Summation of all elements, sum of all elements of an array divided by the total number of elements will return as the average or the mean of, that particular object. Right. So the what does mean function does is, mean function will return as the average of the specified array. Okay, it calculates the average of all the values and that is what it is going to return as. And in the same way, we can also calculate the overall average, average for all the columns, average for all the rows. How you are able to control it? I'm able to do it using axis parameter. There is a parameter called axis inside the mean function. Like how we have under max and min, a max and a min functions. In the same way, in mean function, we have axis parameter. Okay. So let me go with the hands-on part. Right. I'm coming up with the list object. Okay. So I'm converting this list object to array object. Done. And I'm printing this array. I'm done with the array as well. Okay. Then I'm going to use the mean function from Numpy. I'm going to use mean function from Numpy where I am passing a. So when I pass a, it takes all the elements, all the values of a will be considered, and it adds up all these values. What is the output of the summation? 1 plus 2 plus 3 plus so on. So it will be 1 plus 2, 3, 3 plus 3 will be 6, 6 plus 4 will be 10, 10 plus 2 will be 12, 12 plus 1 will be 13, 13 plus 3 will be 16, 16 plus 4 will be 20, 20 plus 2 will be 22, divided by 9. So 22 divided by 9 will be around 2 point something. So the 2 point something should be written as mean value, 2.444 so on. Observe. Okay. Right. In the same way, can I calculate the mean for all the columns? Yes. By using the axis parameter, keeping it as 0. Keeping it as 0 will return me the average, the mean for all the columns. So let me do it, guys. 1 plus 4 plus 3 is nothing but 8 by 3. It will be around 2 point something, and here also it will be 2 point something, but in the last column it will be exactly 2. Why? 3 plus 1 plus 2 is 6. 6 divided by 3 will be 2. But as we are using a function like mean, it returns all the output in floating values. So the output will be 2 point. Let me print the results. See. For the first column, for the second column, and for the third column. Clear? In the same way, what we are doing? I'm calculating the mean, but this time for rows. This time for rows. So it considers all the rows. So the same values will be written. See, 1 plus 2 plus 3 will be 6. 6 divided by 3 will be 2 point something, 2.0. Then for the second row, 4 plus 2 plus 1, 7 divided by 3, 2.3 so on. And finally 3 plus 4, 7 plus 2 is 9. 9 divided by 3 will be 3.0. So these will be the values of each and every row. See. Good. So that is how I'm able to calculate the average. Using mean function, I can calculate the average. The overall average can be calculated. The average for all the columns can be calculated, as well as for all the rows can also be calculated. Right? Next to the mean function, we have median function. What does median function does? Median function will return as the middlemost value of ordered data. Median function will return as the middlemost value. Fine. How it is going to return as the middlemost value is, it will sort the data in ascending or descending. Okay. So when the data is sorted in ascending or descending, the middle value that we'll have will be written as output by median function. So if it is in case of odd number of observations, we can get the center. What in the case of even number of elements? It is going to take the average of the middle two values. What are the middle two values that we have? The average of these two values will be returned as output. Okay. So same. Overall median can be calculated. Only median can be calculated for all the columns. Median can also be calculated for all the rows. Yes. By using the axis parameter, by passing the value for the axis parameter, we can calculate the median for rows and columns, for all the rows and for all the columns. Right. So what I'll do is, I'll create first of all, I'll come up with a list object, and that list object I'm converting into an array object, and I'm printing that array object. It's a two-dimensional array object of size 3, 3. Now, I'm using median function from Numpy. What does median function does? Median function will actually sort all elements. So all these elements will be sorted in either ascending or descending order. Okay. Then it is going to return us the middlemost value. So when you take all these elements, how many elements we have? 9 elements. Let me arrange them in ascending order. 1, then 1, comma 2. How many twos? 3 twos. 2, 2. How many threes? 2 threes. 3, 3. How many fours? 2 fours. 4, 4. So these are your elements arranged in ascending order. Now, if I ask you to calculate median, what is the middlemost value? Just calculate. 1, 4. 1, 4. 2, 3. 2, 3. So what is the middlemost value left out is? It is 2. That is how the median gets calculated. I am calculating the median. Median of the entire array. But what if I want to calculate the median for each and every column? So initially it takes each and every column values. It gets arranged. So here the output will be 3. Here the output will be 2. Here the output will be 2. So the output will be 3, 2, 2. If I do the same with respect to the rows, so it will be 2, then 2 and 3. Am I right or wrong? Am I right or wrong, guys? So let us check the results. What I'll do is I'll start execute from line number 637. So I got it as 2.0. Yes, as we are using functions like mean, median, it always returns the values in floating points. Okay, right. So here also it will return the values for all the columns. See, 3 point, 2 point, 2 point. Yes. For rows, for all the rows, 2.2.3. See. Clear? Fine. We had an example for odd number of observations. Let me also try this using even number of observations, guys. Let me do it with even number of observations. If you observe here, we just had only 2 and 2 values in each row and each column. So this is my array, okay, in which there are 2 rows in each row and 2 values in each column. So in the earlier example, we had experience with odd number of values, but here we are going to have even number of values, right? So when I say np dot median of a, what will be the output? It considers all the values. 1 plus 2 plus 3 plus 4, it is 10. 10 divided by 4 will be 2.5. 2.5 will be written as output. See? Then I want the median to be calculated for each and every column. As we have even number of observations in both the columns, it takes the average 2 plus 4 divided by 2, 3 plus 1 divided by 2. So what will be the output, guys? 6 divided by 2, 3.0, and 4 divided by 2 will be 4.0. So for line number 653, it will be 3.0 and 2.0. Done? I'll do the same for rows. First row, second row. 5 by 2 and 5 by 2. It should be 2.5 and 2.5. 2.5 and 2.5. So that is how we use the median function from Numpy module. For odd number of observations, we can directly go for the middlemost value. But in case of even number of observations, we have to take the average of the middlemost two values. Right. Let me go to the next function. Next statistical function that we have is variance. What is the next function in the sequence? It is variance. So what does this variance function does? Variance function will actually return the spread. How do we calculate variance? Variance is calculated in this way, guys. Square root of mean. What is mean? Nothing but average minus xi represents your data divided by your n. So summation. Okay. So this will return as the variance value. This will return as the variance value. You can calculate the variance of the entire array, or for all the columns you can calculate the variance, as well as for all the rows also you can calculate the entire variance. What is the function that we use for calculating the variance? It is VAR. VAR from Numpy. Right? So let me use this VAR from Numpy. So initially I'm creating a list object. I'm converting into an array. It is a two-dimensional object of size 3 by 3. What are we doing in line number 669? I'm using variance function from Numpy. So what happens here is, initially the mean of the entire value will be created and it substitute all the values in this formula, guys. Okay. So the variance value will be calculated by substituting all the values of the array in this formula. Okay. So this will return me the variance value. What is the variance value? 1.135. 1.135 will be written as output. Can you also calculate the variance for the columns, for all the columns? Yes. For all the three individual columns, the variance can be calculated. How? By taking only the first three elements from column 1, it will calculate, it substitutes the values into this formula and it calculates the variance. Then the same for column 2, then the same for column 3. So this will return me the variance for all the columns. For all the three different columns, these are the variance values. Right? Yes. And finally, I can also calculate the variance for all the rows. How? By changing the axis value, by keeping the axis value as 1, it returns me the variance written for all the rows. See. Clear? Then next to variance, we have standard deviation. What is standard deviation? Standard deviation will return me square root of variance value. How is standard deviation calculated? Standard deviation is calculated using square root of variance. So far we have calculated variance, right? Now we can calculate standard deviation by applying square root on the variance. So we can calculate standard deviation for the entire array object, for all the columns separately, for all the rows separately. By maintaining the value for the axis 0 and 1, we can get the standard deviation calculated for all the columns and all the rows. Right. So what I'll do here is, yes. So initially let me calculate the variance, then I'll go for the standard deviation. For that I'm creating a array object A. So this is my array object on which I'm going to calculate both variance and standard deviation. See, what am I doing? I'm calculating variance. np.var will return me the variance of the entire array object. See, 1.135. Okay, if I go and calculate the standard deviation of A, just apply the square root on 1.135. That will be written as standard deviation. It is 1.06. 1.06 is the standard deviation for the entire array, for the overall elements of the array. In the same way, let me calculate the variance for the elements with respect to column wise. For all these columns, I am going to calculate the variance. Okay. So what are the results? The results are here. Can I calculate the standard deviation? Yes. Just apply the square root on these values. When you apply the square root on these values, it will return me the standard deviation for all the columns. See. And finally, variance for all the rows and standard deviation for all the rows. Applying square root on the values of the variance will return me the standard deviation. Okay, so this is how we have calculated all the different statistical measures like mean, median, okay, minimum, maximum, right? Then coming to the mode function, if you observe for mode, in Numpy, we don't have any function called mode. There is no Numpy module does not contain the function mode. Then how can we calculate the mode is, we can calculate the mode from statistics module. There is a module called statistics. Okay. So this module will return me, within this module, we have function called mode. And what does mode means? Mode will return the most repeated value. Most repeated value will be written as the output for mode. Right. So I'm importing statistics like how we have imported Numpy. In the same way, you have to import statistics. And I'm also providing an alias name for statistics. What is it? S. S is the statistics alias name. And I'm also coming up with a list object. So as we cannot perform the mode calculations on Numpy, I'm going to perform the mode calculations on the list object. So I'm passing the list to the mode function from statistics, s dot mode of. What is s? S is nothing but statistics. From statistics, I'm using a function like mode. Okay. So to this mode, what am I passing? I'm passing the list object. So this will return me the most repeated element. What is the most repeated element? It is 10. So 10 will be returned as output. 10 will be returned as output. In the same way, can you tell me the output for line number 714? For the next line? What we are doing in the line number 714? I am defining one more list object. And I am passing this list object to the mode function. When I pass the list object to the mode function, it identifies the most repeated element. What is the most repeated element? It's 10 and 20. If you observe, 10 is repeated for twice. Even 20 is also repeated for twice. But mode function will return only 10. The reason being, we are supposed to get both 10 and 20 as output. The reason is, both 10 and 20 are repeating for twice. But why did we get only 10 is, mode function will return only one output. In order to get all the elements with the highest frequency, like both 10 and 20, if you want to get both 10 and 20 as output, we have to go and use multi-mode from statistics module. If you see here in line number 719, I am trying to use multi-mode function. So let me create the list object first of all. And when I say s dot mode of L1, can you tell me what will be the output for line number 718? It will be 20. Why? 20 is appearing first. If you compare 10 and 20, 20 appears first. But multi-mode will return both 20 and 10. Mode will return only one value as output, whereas multi-mode will return as both. Next to it, I am converting this list object to array. Fine. And now I am trying to perform the mode calculations on array. So do you think will it return output? Yes. A is an array object, guys. A is an array object which contains in total 8 elements. See, let me open it. Okay, so I can also get the multi-mode from the array object. What will be the output? Both 20 and 10. So the mode function that we have discussed is not available in the Numpy module. So we are using it from statistics module. Like how we have imported Numpy, in the same way we have to import statistics module as well. Clear? Alright. So this marks the end of statistical operations on n-dimensional array objects. Let us go to the next topic. It is sorting arrays. Can we sort elements of array? Yes, we can sort the elements of array. Okay, so the next topic that we have is sorting arrays. So what is the function that we are going to use for sorting the arrays? What exactly sorting means, we'll understand. Right, when you are given with an array object, and if you want to sort it, if you want to order the elements of the array object, you can go and perform sorting. So this sorting is nothing but you are going to arrange the elements of the array in either ascending or descending. So by default, it performs ascending. Fine. If you are actually having, if you are going to work out on, say, numbers, numeric values, okay, we are able to arrange them in ascending or descending order. But what if we are having elements like alphabets? When you have alphabets as your elements in array, so still we can do the sorting using the alphabetical order. Alphabetical order will be used for sorting. And in order to sort the elements of array, we have a function in Python called sort. From Numpy, there is a function called sort, and this sort function helps us to sort the elements of arrays. Okay, so let us try exploring the how sort function works, and we'll explore on one dimensional, two dimensional, so on. Right? Yes. I'll start from importing the Numpy, Numpy module. So initially I'll import the Numpy module as np. Done. Then next to that, I'm going to convert a list object. What is this? This is the list object, and I'm converting it to an array object using np.array function. When I use this array function, we know that it helps us to convert any traditional object, Python object, to array. So this will return me a one-dimensional array. See? So this is my one-dimensional array of size 4, 0, 1, 2, 3. 3201, right? So when I say np dot sort of arr, what is arr? Arr represents an array object. So what am I doing? I am sorting the elements of array. How? Using a function from NumPy, it is sort. Using a function from NumPy, it is sort. So what happens? What will be the output? It sorts the elements of the array ARR and it returns me the output as 0, 1, 2, 3. Ascending order. 0, 1, 2, 3 will be returned as output. What if I take the elements of the array as alphabets? See, if you observe, all the elements of the array, the list are str type, right? I'm converting it to an array object. Done. Can I still sort them? Yes. I can sort the elements still based on alphabetical order. So can you tell me, can you go for a guess what will be the output for line number 737? When I go and use sort function from NumPy, which alphabet comes first initially? Obviously apple, then banana, then cherry. So that will be written as output. Apple, banana, cherry will be written as output, sorting the elements of array. Then next to it, what if I have Boolean values? Good. What if I have Boolean values? Can I still sort them? Yes, you can. How? Based on the alphabetical order? No. It's not based on the alphabetical order. Internally, false is considered as 0 and true is considered as 1. So, if you have an array object with only Boolean values, true, false, true, and when you are trying to sort these elements, the Boolean values, it gets sorted based on the value that it is considered. So the output will be false, true, true. Why? Internally, false is referred as 0. True is referred as 1. So based on the values, it gets sorted. Right. So far we have experimented only on one-dimensional arrays. Let me do it on two-dimensional arrays, guys. Because in two-dimensional arrays we'll have both rows and columns. Two dimensions. Can we still sort them? Yes, we can still sort them. Right. So I'm importing Numpy once again and I'm coming up with a two-dimensional array. So this is my two-dimensional array. Okay. Now I'm going to perform sort. I'm using sort function from Numpy and I'm passing this two-dimensional array as input. So what happens? The elements of this two-dimensional array will be sorted in such a way based on rows initially. See, 324 became 234 and 501 became 015. Clear? So, based on the row level, the elements got sorted. Fine. I am taking a one-dimensional array one more time. So, this is my array object. Now, I am sorting. We know when it sorts, by default, it sorts in ascending order. The sort function from NumPy sorts the elements of the array in ascending order. Minus 37, 8, 20, so on, 160. What does this mean? What are we performing in line number 754? In 754, I'm actually using the sort function from NumPy. Okay, I'm using the sort function from NumPy. So this will actually return the elements in ascending order, right? But what is this additional line of code here? What does this mean? This means slicing. This means slicing. What does it mean? It means to return all the elements of the array in the reverse direction. So, even though if you are going to get the elements of the result of the sort in ascending order, since I have used this slicing operation, okay, so the result will be in descending order. See, 160, 110, 90, so on, minus 30. That is because of the slicing operation that we have done. And when I say a dot shape, what is the shape of a? It is just 9 comma. It's a one-dimensional array which contains 9 elements. Clear? So what am I doing? I'm sorting A based on column wise. Okay, where the axis is equals to 0, which means column wise. First of all, A contains what is the dimension of A? It is a one-dimensional array which contains only the columns. One row, all 9 columns, right? So can I sort? Yes. So this will sort the values of A in ascending order, and when I print, I'll get all the values. So if you see here, sort of A has returned me in ascending order. But when you take A is in the same manner, guys. It did not change. It is not performing the in place operation. Right? What am I doing in line number 760? I'm going with row wise sorting. Will it allow me to perform sorting in row wise? No. Why? Because A is a one-dimensional array which contains only one row. How is it possible to sort the elements of A row wise? It has to raise an exception. Axis error is what we have written. Why? If it is a two-dimensional array, yes, it would have sorted. But it's A one-dimensional array that we are actually working on. That is why it has written as error. And next to sorting, we have delete function from NumPy. What does this delete function does? The delete function in NumPy actually helps us to delete elements. The specified elements can be deleted based on their index position, guys. By specifying the index position of the element that you want to delete, you can delete the elements. And if you observe the syntax for delete, numpy.delete function of the array object followed by the obj. Obj means the object index. Whatever the element that you want to delete, the element index you have to pass here next to the axis. What does axis means? Axis is talking about along which axis you want to delete the elements. So 0 represents for rows and 1 represents for columns. Here the values got changed. 0 is for rows, 1 for columns. Okay, so that means I can also delete the elements based on their index position. Not only sorting, but additionally deleting is also possible. How? How are we deleting? Are we specifying the element? No, we are specifying the index of the element. Okay, so let us give a try. Let us understand how we are able to delete the elements of arrays. What are we doing in line number 773? We are, defining a one-dimensional array and storing in ARR. So this is my one-dimensional array. Then what am I doing? I'm using delete function from NumPy. Okay, so this delete function from NumPy will actually help us to delete an element based on the specified index. So it means I want to delete an element from ARR. What is ARR? ARR is an array. From this array, I want to delete the element which is present at index position 2. What is the element that we have at index position 2? 0, 1, 2. That means 6 gets deleted from ARR. See, let me do it. Do you find 6? No. 6 is the element which gets deleted. Yes, good. Fine. Here I have just deleted only one element. But what if I want to delete multiple elements? Even though if you want to delete multiple elements, specify all the index positions. The indexes of all these multiple elements should be specified and pass them as a list object. See, I am coming up with one more array object, storing in ARR, and then I am using delete function from NumPy. What I have to delete? I have to delete the elements from ARR. From this array, I want to delete some elements. What are the elements that I want to delete? Do I want to delete 1, 2, 3? First of all, do I have 1, 2, 3? No. It means I want to delete the elements which are at the position, index position 1, 2 and 3. So what are the elements that we have at index positions 1, 2, 3 in this array? It is 5, 6 and 7. 5, 6 and 7 are the elements, that we have at the positions, index positions 1, 2 and 3. So these 3 elements will be deleted and rest of the elements will be returned. Good. See, 4, 8, 9, 10, 11 will be returned as output. It is very easy in case of one-dimensional arrays. What if I want to perform the delete operation? What if I want to perform the delete operation from a two-dimensional array? So let us do it as well, guys. First of all, I'm coming up with a two-dimensional array. Okay, I'm building a two-dimensional array, and this is my two-dimensional array. See, what is the size of the two-dimensional array? 3 by 4, 3 rows and 4 columns. 3 rows and 4 columns. It's a two-dimensional array. Now, let me start deleting the elements from two-dimensional array. The advantage that you get from two-dimensional array is you can also delete the element not just by specifying the index. Okay, you can also specify the whether it is from rows or columns. Whether you want to delete it from rows or columns. So what does axis is equals to 1 means? Axis is equals to 1 represents columns. As axis is equals to 1 represents columns. Right. Now tell me which element are we deleting from the array ARR2D. In line number 801, what is the element that we are trying to delete? Yes. What is the element that we are trying to delete here? Array. In this array, I want to delete an element which is at index position 1. Okay. But what is the axis that we have specified? Axis that we have specified is 1. 1 means columns. It means columns. So that means in column level. In column level, I want to delete the column which is at the axis, sorry, which is at the index 1. So this column has index 1. This column has index 0, 1, 2 and 3. So that means this entire column will be deleted. No, 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 no. That is where you have to pay attention. See, axis is equals to 1 means columns. What are columns? Column 1, column 2, column 3, column 4. Okay. So out of these columns, which column has index 1? Index 1 means this column 12, 22, 32. Okay. So this column will be deleted. Let us execute and check. Let us execute and cross check our results. See. Do you see that column starting with the element 12, 12, 22, 32? It was removed. It was deleted. Yes. In the same way, let us do some more examples on two-dimensional arrays with respect to the delete operation. So I'm coming with a two-dimensional array. Then I'm using this delete function from Numpy. But what columns are we deleting? And tell me what will be the output for it is same, right? Yes. So from this two-dimensional array, tell me what will be the output after deleting, after executing line number 809. What are the things that we are deleting? It is very clear that we are deleting columns. It is very clear that we are deleting columns. Axis is equals to 1. But instead of specifying one value, I went with 2. What does 2 comma 3 means? Index 2, index 3 means column 3 and column 4 is what we are deleting. Column 3, column 4 will be deleted. So that means we'll have only column 1 and 2. Yes, we'll have only column 1, column 2 as output. Good. One more example. This time I'm taking the same two-dimensional array. Okay. But what are we doing? Are we deleting rows or columns? We are going with rows. Axis equals to 0 represents rows. So the row with the index 0 gets deleted, which will return us only the second row and the third row as output. See. Simple. Understand whether you are performing the delete operation, whether with respect to row or column. Then check for the index. Accordingly, you can answer the question. Am I right? Yes. Now, on this output that we have got, on this array ARR2D, I am going to perform the delete operation. Okay. Is it rows or columns? It is rows because axis equals to 0 represents rows. Perfect. But what are the rows that we are trying to remove? What are the rows that we are trying to remove here? What are the indexes that we have specified? We have specified the indexes as 1 and 2. Both 1 and 2 are specified. Yes, we are trying to remove index 1, row index 1 and row index 2. First of all, you tell me, do I have row index 1? Yes, because this is representing row index 0 and the second one is representing row index 1. But what about row index 2? Is there any third row? No, I don't see 3 rows. There are only 2 rows, guys. There are only 2 rows. So what might be the result? I'm trying to delete rows of indexes 1 and 2. I see only index 1. Where is index 2? There is no index 2. So this has to return as exception. An error has to be raised. Exactly. So let me execute line number 822 and see what will be the result. See. Index error. Index 2 is out of the bond. So there is no index 2 for rows. For axis 0 means rows, which is actually size of 2. Right? So when I say print of array of 2D, this will return as the same two-dimensional, array of 2 rows. Done? Yes. One last example with respect to the delete function. What are we doing here? I'm performing the delete operation. I'm using the delete function from Numpy NP. Okay. So I'm going to delete I have specified a number. Let me keep it aside. Okay. So what is the array that I am using? I'm using the same array, ARR2D. So the same array is what I'm using. But I did not specify whether it is axis 0 or axis is 1. So that means when I don't specify, by default axis will be none. Axis will be none. When the axis is none, what does this 2 indicate? The 2 indicates an index number only, guys. It is indicating the index number only. But how can you interpret what exactly is 2 means? When especially you are not specifying the axis, by default it goes for the indexes. See, the indexes number will be like this: 0, 1, 2, 3. Then it goes to the second row: 4, 5, 6, 7. So now it will map with the index. So out of all these 8 elements, which element is at index position 2? 23 is the element with the index 2. That means we are going to delete the element 23. We are going to delete the element 23 from this 2D array. So when you delete this, obviously what happens is you're left out with only 7 elements. So it will convert into a one-dimensional array, and that one-dimensional array will be written as output. See. So 23 gets removed and I'm printing the results, the output. You will not find 23 no more. So this is very important because see, it's very easy for us to tell whether when we are specified with the axis. When the axis is specified, you can tell which row or which column you are removing, which column you are deleting. Based on the index, you are able to tell. But when the axis is not provided, but still we have to tell which element is also being removed, which element is we are deleting. Clear? Right. So the final topic of Numpy is, selecting the elements based on condition. Okay. So based on the condition, we can also select the elements. That is possible. So for that we have two different conditions, approaches. So let us understand both the approaches, then we'll go for the hands-on. Okay, right. How can we select elements based on the condition? Okay, for that we have two approaches. The first approach says prepare a Boolean array. That means prepare an array which contains only true false values. Is this an array? Yes. Prepare an array with Boolean values is what we have to do initially. Then, what does this true false represent is, true means the condition satisfied. What does false means? False means the condition is not satisfied. Okay. By using this array, what we do is, we pass this bool array as we pass this Boolean array to the n-dimensional array object. If you observe the syntax, nd array of bool array. The array object I'm using, and if I pass the Boolean array to it, so what exactly happens is, it will return us only the elements which contain the value true. It maps, okay, these true false, whatever the Boolean values that we have in the Boolean array will be mapped with the elements of the nd array, and wherever the value is true, only that specific corresponding value will be returned as output. So this is one way of selecting the elements, and the other way is you directly pass the Boolean array. Instead of preparing and doing it all, you directly pass. Here we have prepared and then we have passed. What am I doing is, I'll directly specify the condition. When I specify the condition, I'll get the Boolean array. Once after getting the Boolean array, internally it returns the same. Internally it is going to return as the same. Okay. So I'll take an example for both the approaches and you'll observe, right, how we are able to select the elements based on different conditions. I'll go with the small examples initially. See, I'm importing Numpy as NP to use all the functions, the classes and all. Then I have a list object which contains both positive integers and negative integers. Is this a list object? Yes. All the elements are organized in square braces. All of them are comma separated. Yes. So this is a list object of size 7. And let me print the list. And let me print the list object L. Done. The list object got printed. The list I have, I'm passing it to the array function and I'll convert this list to a array. Where am I storing it? In A. So this is my array object. Now I'm coming up with a condition. I'm coming up with a condition. What is this condition say? The condition says A greater than 0. What is A? A is nothing but array. What is greater than? Greater than is a relational operator, a conditional operator. We know a conditional operator will always return either true or false. Right? So that means for all the values of A, we are actually checking whether they are greater than or greater than 0 or not. So it checks for each and every value and it returns true or false. For 10, it returns true. For 21, it returns true. For 30, minus 34, it returns false. For minus 45, it returns false. Why? All of these values are less than 0. Right? So, when I say B A greater than 0, it checks for each and every value of the array. Each and every element of the array will be checked for the condition and the Boolean values will be returned. So, those Boolean values I am storing in B. So, B will be a Boolean array. See, let me print that Boolean array to the console. See. Hope you are able to map it. How did we get true, true, false, true, false, true, false? The condition is what it is checking. If the condition is met, it returns true. If the condition is not met, it returns false. Okay. Once after having the Boolean array, you pass it to the array. When you say A of B, what is A? A is your actual array. And what is B? B is your Boolean array. When you say A of B, wherever we have the true values, only the values that are corresponding to the true, those values will be returned. See, that is how I am able to select the elements. How did I fetch only 10, 21, 23, 30? Based on, the condition. I have specified the condition. I got the Boolean array and that Boolean array I have used and I have got only the elements wherever the condition is met. What is the alternate approach? Instead of you going it in multiple lines, why don't you specify in one line? Simple, job done. A of, what is B? B is nothing but A greater than 0, right? Specify in one line. So this will return me the Boolean array. So where I'll get all these values once again. Wherever we have the true values, only those elements will be returned. So this is approach 2. At the end of the day, the output will be same. There is no change in the output. But you decide whether you want to keep your code lengthy or very concise. Okay. So I hope you are getting the point. How did I select the positive elements from this ND array? By specifying the condition. Based on this condition, I am able to fetch only the positive elements. In the same way, can I only fetch the negative elements? Yes. I'll reverse the condition. Instead of greater than 0, I'll specify less than 0. So the same list object converting into array. So let me go with the first approach. What does the first approach says? You have to build the Boolean array first. So this is where it will return me the Boolean array. A less than 0 will return me the Boolean array. I'm capturing all the values of the bools in B. So B will be my Boolean array. And when I say A of B, it will return me only the values of true. That means minus 34, minus 45, minus 40. So we were able to select only the negative elements. Right? If you want to keep it very less lines of code, just go in approach 2. Simply A of A less than 0. This will return me, this will select only the negative elements. The elements less than 0. Clear, guys? One more use case. I want you guys to respond here. I am coming up with an array object. Okay, so this is our array and we have two conditions. We have specified two conditions and I want you guys to tell me what will be the output for line number 865 and 866. Understand the condition first and tell me what will be the output for 865 and 866. What are the conditions that we specified? What is the condition, guys? The condition is very clear. A percentage 2. That means we are using modulus operator and we are dividing the values of A with 2. If the remainder is 0, if the remainder when we divide with the elements of A with 2, if the remainder is 0, then it will return true as output. So in short, 865 will return me all the even elements, in array A. If they are even, obviously the remainder will be 0, right? So all elements which are even will be returned as output. That is how I am selecting the even elements. See, 20, 46 and 12 are written. What if the remainder is not 0? It means it is returning me the odd elements. So I have come up with two conditions to select both even and odd elements. Both even and odd elements is what I have selected. And one more example, the final example of Numpy series. Focus. I have a one-dimensional array and using reshape function, I'm converting this one-dimensional to two-dimensional array where the size is 3 by 3. So what will be the B? B is a two-dimensional array of size 3 rows and 3 columns. Fine. I'm coming up with the condition. What does the condition say? The condition says B percentage 3 is equals to 0. Which means when you are dividing with the elements of B with 3, if it leaves the remainder as 0, for those elements we'll mark it as true. So this will capture me a Boolean array. So that Boolean array will be stored in M3. See, since we are working on two-dimensional array, this is how it gets stored. Why it has written only true in the last column? Because all the values in the last column are multiples of 3. 30, 60, 90. Right? Yes. So when I say B of M3, this will return me only the elements which has the bool value as true. Okay. Wherever the condition is satisfied, only those elements will be returned. So what will be the output? The output will be 30, 60, 90. 30, 60, 90 will be returned as output. Can I also do it in the reverse alternative approach? Approach 2, yes. Instead of doing it multiple lines, specify the condition within the square braces. So this will generate the Boolean array and that will be passed to the B and it will return anyhow the output will be same 30, 60 and 90. Yes. Yes. So this marks the end of Numpy. We have understood each and every concept, guys. We haven't missed out any concept from NumPy. Okay, starting from the number of approaches. How should we create these array objects? Then the indexing and slicing operations. Very, very important topic. Advanced indexing. We have understood. Followed by, arithmetic operations, statistical operations, sorting arrays, deleting the elements of arrays, and finally we were able to select the elements based on the conditions, right? So we have discussed one dimensional, two dimensional, three dimensional and multi-dimensional array examples as well. Okay, so if you have missed out any of the sessions of NumPy, go and watch the previous two sessions so that you'll have the continuity, right? Yes. So if you find the session went well, do hit on the like button and also, yes, it's time for your questions. Any questions? Come on guys, any questions related to NumPy? Do hit on the like button and also share across your connections guys. Because we are going to come up with some more valuable sessions in the future. So also ensure that you have subscribed to our channel. And if you have any kind of technical questions, feel free to ask your questions. Yes, the feedback link has been posted. Give your valuable feedback before you leave. as well as hit on the like button, guys. Encourage us.